This is an apple, and this is gravity. Now, the reason that falls to the earth is because gravity is pulling it down, but you see, I've been working out, which means I'm actually stronger than gravity, so I can pick it back up again. I may be able to pick up this apple on Earth, but the bigger the planet, the stronger the gravity. And at a certain point, nothing can escape it. Not this apple, not big, strong, sexy me, not even light. When nothing can escape, it becomes a black hole. To create a black hole in Nottingham would not only destroy the county, but the country and the rest of the solar system as well. So experimenting on them can be what the experts call tricky. But when there's a will, there's a way. You've been creating black holes in a bath.
Yep. So what we've got is we've got a hole in the centre, and then we've got a pump here just at the back. And what we do is we send water in up through the pump, and it comes in through this inlet here. And then because it's coming in through just this one side, it's going to spiral around with some angular momentum. And then as the thing fills up, it's going to be draining in through the centre, and that's how we create our vortex flow. We've got space-time, which is kind of spinning in the ergosphere, but then we've got the event horizon, and the event horizon is, once you've gone past that, nothing can escape from it, and this is where we draw the analogy, because that's the same as the drain in our experiment.
So it's believed that black holes can spin, right? This energy is called angular momentum. You can't slow them down with friction like you would do with a car brake on account of how gravity would tear you apart. So the question facing scientists is,
how do rotating black holes lose their angular momentum? And the mechanism, which we believe is responsible for this spin down, is called superradiance. And it's an effect where a wave interacts with a rotating body, and the wave impinging on this rotating body comes out with a higher energy. And that works by giving negative energy to the rotating body. But energy has to be conserved, so through this process the wave gains energy, it steals angular momentum from the rotating body. But up until now there was no single experimental evidence that this effect actually occurs.
does it prove that that effect is true?
In all these years, this is the first experimental evidence that that process actually occurs in nature.
I'm going to take that as a yes. Science 1, Mysteries of the Universe 0. 0? Well, you get the picture. Richard Minkley for Knots Tonight.